Hello grade 11s. Today I'm looking at the Loci section, and this is the CAM on page 107 from your workbooks. Now they're working backwards really. So in this example here they've given you the CAM, and what they want you to do is then draw the displacement graph. So we're going to have to put in our pizza slices and then find where specific points are and then project them back into a displacement graph here. Let's just read through what it says in the instructions. CAM profile with a wedged end follower. Yes. The CAM rotates with constant velocity in an anti-clockwise direction. Draw the displacement graph for the CAM using a horizontal scale of 8 mm equals 30 degrees. Indicate the direction of rotation of the CAM profile. Label the displacement graph and indicate the scale used. Show all necessary construction. So I now need to project my height across here and mark off my divisions of 8 mm for every 30 degrees. Then I'm going to put in my pizza slices here and transfer all those measurements back to my vertical line and then project them into the displacement graph. I have projected my height across and I've marked off my 8 mm splits, my 12 times 8, so that's 96 here. And we would do the labeling now. So there are my three labels: displacement graph, scale of 8 to 30 degrees and scale of 1 to 1, and we've done the pizza slice segments of 30 degrees. Now I need to hatch my shaft, and then I'm going to put in my pizza slices. Here are my basic pizza slices. Now when I look at this shape though, there's a significant jump from this point, and there looks like a change in this point here. So what I want to just check and see is if that comes in a 15 degree angle. So here I've put my 45 degree on top of my 30 degree set square, and that does look fairly relevant to hit that point. If I flip that around, I've got my 30 degree on top of the 45 degree here. So this is my 15, and that also looks quite relevant to that point there as well. So let's start labeling. Remember, wherever the follower is, that is always 0. Our direction of rotation is anti-clockwise. So we're going to label in a clockwise direction. That's 15, so this is going to be a 105. Now let's take our measurements back. So if I take my point to my 30, there was 30 degrees. Get my distance to 60. Distance to 90. Let's transfer those back. So that must go to the 30. This is going to 60. This is going to 90. Now another thing we could do is if we extend this line, and we could take our measurements at that point. So our next point is 105. It's not a great example, but if I take there's 105, we obviously have to split this in half. So there's my point 4. If I just extend these lines, what you could do is then just take the distance. So there's my 105 distance. I come and put it down here, and then I can mark it off like that straight away. Here's 120. 120 to 150 is a dwell period. That looked like from 105 as well, same measurement. Then we can go to 180. And if we just put it down here on this line, that's going to give us our points here. 210. Remember, the other way we can be doing it is still transferring it around. So if I bring this around, here's my mark for 240, and then I would project it. $255 to $270 looks like a dwell period here. All the way to 300, that's a dwell period. So 255, I'm going to just put a mark here and work that out later. Or obviously just mark it off on 270 and 300, because that would give you the same dwell. There's my height of 330. And 360 down at the bottom there. Let's join those points up. As I'm joining these points, you can see they are on uniform velocity, so the lines actually line up with each other. And I'm going to show this all. And there is the displacement graph for this drawing on page 107.